Hi. We are discussing about the 30 days of Verilog lecture series, no? So now we are in day 9. So day 9, I'm going to explain the flip-flops, okay, operation of flip-flops. I'm going to execute in EDA Playground, Vivado, and Quartus Prime and Model Sim. So I will divide this day 9 video into two equal parts. So first part, I will explain you SR flip-flop and D flip-flop. And second part, in second video, I will explain you the operation of JK flip-flop and a T flip-flop. Okay. So now we'll discuss about SR flip-flop and next to D flip-flop. Okay. So from SR you will get D flip-flop. From JK we'll get T flip-flop. Like that I divided. Okay. So first I will execute this code in the EDA playground. So for that first take this SR flip-flop. First I will explain the code. So if you see, I will explain the code and as well as test bench. So module, what is my module name? SR flip-flop synchronous reset. Okay. So there are two types of resets will be available. That is synchronous reset and asynchronous reset. Okay. Synchronous reset means what? So that reset will be going from reset mode to functional mode or functional mode to reset mode. That is actually synchronous with the clock. That's why we call it synchronous reset. So when you are using this synchronous reset, so no need to use that reset in the this sensitivity list. Okay. So I'm declaring the inputs, input clock, input reset, and input S and input R. Okay. Output reg queue. So why I'm using reg data type means this queue I'm using in the behavioral statements. Okay. So this is the procedural block. Okay. This is a behavioral modeling style. So we are using always at the rate passage of clock begin if reset equal to 1, okay, Q should be initialized to what? 0. So this is actually active high reset, synchronous active high reset, okay. Else, so I'm checking. So case S comma R. So two tick binary 1 0. So 1 0 means Q will be initialized to set state, okay. And when S and R are 1 0, Q will be initialized to set state. And when S and R are 0 1, Q will be initialized to reset state. So here I'm using non-blocking assignment. And for the every case statement, there is a default statement. So default is what? It will be in the previous state only. Q is non-blocking with Q, end case, end and end module. Okay. So this is my Verilog code, RTL code for SR flip-flop with synchronous reset. Okay. And coming to the test bench, so module SR flip-flop synchronous reset underscore TB. Okay. This is my TB file. Okay. As test bench doesn't consist of inputs and outputs, we have the variables. So reg clock reset S comma R. This clock reset and S comma R I'm declaring with reg data type, and Q I'm declaring with Y data type. So here we need to instantiate our design. Okay, what is our design name? SR flip-flop synchronous reset. No, so this is my design name followed by the instance name, and this is connection by name. Okay, whatever the variables outside the bracket are design inputs and outputs. Inside the bracket are test bench variables. Okay, so here one more step will be added in the test bench for the sequential circuit. We need to generate the clock. Okay, so initial begin, I'm initializing clock equal to 0. I'm using forever hash 5 clock equal to not of clock and end. Okay, so hash 5 means what? What is the time scale I given? 1 nanosecond. So clock should be off for 5 nanoseconds and the clock should be on for 5 nanoseconds. So total clock period is how many nanoseconds? 10 nanoseconds. Okay. So like this, I can generate the clock. Okay. And initial begin. So these are the two instructions for generating the waveform in the EDA playground. Dollar dump file sr flipflop dot vcd dollar dump vars 0 comma sr flipflop synchronous reset underscore tb. Okay. And next I'm applying the reset. First I'm applying the reset. Okay. So when you apply the reset, I'm giving s equal to 0, r equal to 0. Okay. After 15 time minutes, I'm desetting the reset. Okay. So that means I'm making this as functional mode. Okay. So during when reset equal to 1, this will be in reset mode only. Okay. And after 15 time minutes, what I'm doing? I'm making reset equal to 0. So the next, after 10 time minutes, I'm giving the stimulus. That means S equal to 1, R equal to 0. So this we need to get reset state. This is set state. Okay, sorry, set state. And again, after 10 time minutes, S equal to 0, R equal to 1. This is reset state. And S equal to 0, R equal to 0 means this can be latch state. Okay, when it is 0, 0, latch state. After 10 time minutes, I want to means terminate the simulation. That is dollar finish. Okay, and if I want to see the outputs in the log file, okay, or in TCL console, so we can use dollar monitor. The dollar monitor at percentage T, this is for time. Okay, S equal to percentage B, R equal to percentage B, reset equal to percentage B, Q equal to percentage B. This I want to display in the binary. That's why I'm giving a format specifier percentage B, comma, dollar time. This is for time, S, R, reset, comma, Q. Okay. So if there any change in this variable, then it will display. That is dollar monitor. Okay. And end module. Okay. So this is the Verilog code. So this code I want to execute in EDA playground. So copy this code and open the EDA playground. Here I opened. Here we need to paste this code. And next here, this is test bench. So copy this and go to EDA playground. Left side we need to write the test bench. Okay. And tools and simulators. In this we need to select Aldec Rivera and use open EP waveform after run. Save this and run this. So I got the waveform. See here. So that means initially both are like we are getting don't care only. So here if you see when clock equal during the passage of clock we need to see. Why? Because always at the rate passage of clock, no? So during this passage of clock, so S equal to so reset equal to 1 means what? Whatever may be the R and S values, Q will be 0 only. Till here, Q will be 0 only. Why? Because till here, the reset will be activated. Okay. Till 15 time minutes, I need to give the reset, no? So after 15 time minutes, we need to deassert the reset. I need to make the reset to 0. And here I'm checking for what S equal to 0, R equal to 0. So it will be previous state only. And during this passage of clock, my S equal to 1 and R equal to 0. S equal to 1, R equal to 0 means Q will go to set state. See here, Q will go to set state. Okay. And during next passage of clock, okay, it will take for 10 time minutes. During this next passage, I am making S equal to 0 and R equal to 1. So Q should go to reset state. Okay. And during this passage of clock, uh, again I'm making S equal to 0, R equal to 0. So that means it will be in the previous state only or memory state only. So what is the memory state? The previous state is Q is 0 only. So that means this one I need to see. Q is 0. So it will stay in 0 only. Okay. So like this, I can check the waveform in EDA playground. And you can see in the log file also as I wrote the dollar monitor in the test bench. No? So initially when S equal to 0 or equal to 0, reset equal to 1, it will be unknown only. So at 5 time minutes also it is 0. Why? Because reset is activated. Okay. So during 15 time units, reset I am making as 0. So S equal to 0, R equal to 0, Q equal to 0, S equal to 1, R equal to 0. Set state, Q equal to 1, S equal to 0, R equal to 1. Reset state, Q becomes 0. S equal to 0, R equal to 0. So this is memory state. Okay. So like this I can see in the log file also. Okay. So this is how we can execute in EDA playground. Okay. Next, so open the Vivado. So I want to execute in Vivado. Okay. So new project. Next. I'm giving the project name Flipflops. Okay, and we are in day 9, no? So we are in day 9. So this is the project location. Next, this is RTL project. Create create this file name. So give the module name only. Okay. So what is this? SR flip-flop with synchronous reset. Okay. So here choose the location in day 9 flip-flop. Okay. Okay. Next. This is optional only. Next. Okay. Next part number and project summary. Okay. Yeah. Module name also same I want to give. So here my design source is created. So just copy this RTL file, save, and coming to the test bench. This is my test bench file. Copy this and go to simulation sources. Add the simulation order. Create the simulation sources. Paste here. Choose the location. Flip flops. Select. OK. Finish. And module name is also same. So here, this is my TB file. So copy this test bench file. Okay. Copy, and here you paste, save. So now my design file is instantiated in the test bench. Okay. So I want to see the means circuit, how the tool is converting my code into gate level netlist. Okay. I want to see the circuit. After that, I want to see the simulation. Okay. So for seeing the circuit, go to the RTL analysis. In this RTL analysis, open elaborated design. So like this, it is converted in terms of like muxes and D flip-flop, it is converted. Okay. So basically, a D flip-flop mostly we are using in the VLSI. So that's why mostly it will convert in terms of mux is a means universal logic circuit. So if it is if else statement, so our case statement, it will be converted into mux. Okay. And coming to simulation part, run simulation, run behavioral simulation. So you can see the output in the TCL console also. So same whatever we checked in the EDA playground that we are getting. So during zero time period, so S equal to 0, R equal to 0, reset equal to 1, Q equal to X only. And 5000 S equal to 0, R equal to 0, and reset equal to 1, Q equal to 0 only. Why? Because here reset is applied. Okay. So here reset is deactivated. It will go into the functional mode. So 0 0 means previous state, 1 0 means set state, 0 1 means reset state, and 0 0 means again memory state. Okay. And coming to this waveform, fit to page, here you see initially reset is high. Okay. Initially this is don't care up to 50 like that 5 nanoseconds, and this is don't care only. After that, up to 15 nanoseconds, reset is activated. So the output will be 0 only. Okay. And during this passage of clock, I need to check S equal to 0, R equal to 0. So it will be the previous state only, memory state. What is the memory state? 0 only. Okay. And here, if you check S equal to 1 and R equal to 0. So that means it will go into set state. Okay, the Q becomes 1. Okay, and next here S equal to 0 and R equal to 1. So Q becomes 0. Okay, and here S equal to 0, R equal to 0. It will be stay in the memory state. What is the previous state? 0 only, no. So 0 means it will be there in the 0 only. Okay, like this, I can see the waveform for the SR flip-flop. Okay, and coming to the quarters prime. So for this, I created three files. Okay, so what are these three files? Means RTL, simulation, and TB. Okay, so in RTL, we need to write the Verilog code RTL file. RTL files will be saved, and TB we need to write the Testbench files. Okay, we need to write the Testbench files, and in sim we need to save the project. Okay, so new project wizard. Next, so you need to choose the project location where you want to store this project. We are in day 9. Sim. Okay, this is my project folder, and next, here RTL. We are in SR flip-flop. No, so give the module name as project name. Okay, so what is my module name? SR flip-flop synchronous reset. Copy this, and here you paste. One second. Yeah. Next empty project, and you need to upload the RTL file. Okay, so we are in SR flip-flop. No, SR flip-flop. Next, okay, so that has been added here. My RTL file is added. Okay, next, and choose any FPGA family, and next, and finish. So my RTL file is added in this. Okay, so go to analysis and synthesis. Start. Yeah. So I got 0 errors and 1 warning. And go to this netlist viewer, RTL viewer, right click, open. So like this, in the quarters prime, I'm getting like this. Okay, tool is converting our code, RTL code into gate level netlist. Okay, so this is in quarters prime. Coming to model sim. So model sim. So in model sim, we can only see the simulation part. Okay, so project. Okay, I want to close this. Project name I want to give. Okay, what is my project name? Let us take flip-flops. Okay, or here you give this module name only. So this is SR flip-flop, and browse that. So in day 9 sim, this is my folder. Okay, okay, and add the existing files, RTL files, SR synchronous reset. Okay, and TB files, SR synchronous reset. Open. Okay, close. Okay. Next, select these two, right click, compile selected. Yeah. So I got tick mark means both are compiled. Okay. Go to library, work function. Okay. In this work, SR flip flop synchronous reset TB file we need to simulate. Right click and simulate. Simulation starts. Okay. After this, what you need to do here, right click, add waveform, add wave. DUT also I want to add. Okay. So these are my TB files and DUT files. You need to group. These are my TEP files. Right click, group. I'm giving TB, and these are DUT files. Right click, group, DUT. Okay. And go to run all. Okay. No. Here I can see in transcript window also. So view, some transcript window will be there. Okay. Mm, yeah, transcript. Okay. This is my transcript window. So in the transcript window, whatever we checked in the EDA playground and Vivado, that same thing we will get in the transcript window. Okay. So when s equal to 0, r equal to 0, and reset equal to 1, q equal to don't care only. At 500, s equal to 0, r equal to 0, reset equal to 1, q equal to 0 only. Okay. So here I'm deasserting the reset. Okay. So s equal to 0, r equal to 0 means what? It will be memory state only. S equal to 0, r equal to 1 means this will be in set state. Q becomes 1. S equal to 0, r equal to 1 means reset state. S equal to 0, r equal to 0 means memory state. Okay. So I want to see in the waveforms. Just expand this. Yeah. Here you see. Just zoom fit. So initially, don't care only. So till which one the reset is applied here, if you see the reset, reset will be one till this passage, this passage. Okay. Even though the reset is applied, Q will be 0 only. Okay. And here what happens when S equal to 0, R equal to 0, that is Q equal to what? 0 only. And next here we need to check. Here S equal to 1 and R equal to 0. So Q becomes what? 1. Set state. Okay. Here this is set state. Okay. And next coming to this one. So when this one S equal to 0 and R equal to 1, it will be 0. Okay. And S equal to 0, R equal to 0, it will go to the previous memory state. Okay. So like this, we can see the SR flip-flop in EDA playground, Quartus Prime, and Vivado, and Model Sim. Okay. Next, we'll go with D flip-flop. Okay. So how you'll get the D flip-flop from SR flip-flop only? So in the SR flip-flop, we have when S equal to 1 and R equal to 1, that is an invalid state. Okay. So in order to not use that invalid state, we are going for the D flip-flop. So D flip-flop, we are connecting S and R with an inverter such a way that there are two possibilities. That is S equal to 0, R equal to 1, or S equal to 1 and R equal to 0. Okay. So that we also called as sequential buffer. So sequential buffer means what? Whatever the input is there, we are getting at the output. Okay. D flip-flop is also called as a sequential buffer. Okay. So this is the code for D flip-flop. So module D flip-flop, I need to declare input clock, input D, and output reg Q, output Q bar. Okay. And so why reg Q means this Q I am using in the procedural block. Okay. So that's why I need to declare with reg data type. Always at the rate passage of clock. This is a synchronous reset. Okay. Q equal to D. So when during this passage of clock, whatever the D value is there, that is assigned to Q. Okay. And assign Q bar equal to not of Q. Okay. After the procedural block, I need to use Q bar. That's why I not indicated the data type. By default, it will take as white data type only. Okay. As this is white data type, I am using assign statement. Assign Q bar equal to not of Q. Okay. End module. Okay. This is my Verilog code, RTL code. And coming to the test bench module D flip-flop underscore TB. And these are the variables. Okay. Test bench variables. Clock and D are variables for we need to declare with reg data type. and Q and Q bar we need to declare with void data type. You need to instantiate your design in the test bench. How to instantiate? Design name followed by the instance name, and this is connection by name. Okay, connection by name. So the variables in outside the bracket are design inputs and outputs. The variables outside inside the bracket are test bench variables. Next, you need to generate the clock. Initial begin clock equal to, you need to initialize the clock forever hash 5 clock equal to not of clock. Okay. So I need to generate a clock with a period of 10 nanoseconds. Okay. That means that should be off for 5 nanoseconds. That should be on for 5 nanoseconds. Okay. Initial begin. So I want to like means for getting the waveforms in EDA playground, I need to use these two commands. Okay, dollar dump file d flipflop dot vcd dollar dump vars 0 comma d flipflop underscore tb. Okay. Next, I need to give the stimulus. So how to give the stimulus? D equal to 0. After 10 time minutes, I am giving D equal to 1. After 10 time minutes, I am giving D equal to 0. After 10 time minutes, I am giving D equal to 1. Okay. And to terminate the simulation, I need to give dollar finish. Initial begin. Dollar monitor is for for displaying the signals in the log file. Okay, log file or TCL console. Every time if there any change in this variable, then it will display. Okay, so that is dollar monitor end and end module. Okay, so this one I will execute in EDA playground. First EDA playground. Just copy this and go to EDA playground. New here paste this code and test bench. Copy this and go to EDA playground here test bench. Okay, go to tools and simulator Aldec Rivera, open EP waveform, save and run. You got this output. So initially those are don't care only. So during this passage of clock D equal to 0, Q equal to 0, and during this passage of clock D becomes 1, Q becomes 1, and during this passage of clock here this passage of clock. Okay, D equal to 0, Q equal to 0. During this passage of clock, D equal to 1 and Q equal to 1. Just input is following the output. Okay, you can see in the log file also. I checked for this combination. No? Initially, this is don't care only, and D equal to 0, Q equal to 0. D equal to 1, D next here, D equal to 1, Q equal to 1. D equal to 0, Q equal to 0. Again, D equal to 1, Q equal to 1. Like this, I can see. Okay. And coming to the Vivado, close this simulation, close this elaborated design also. So go to the design source, add the design source, create the design source, create, give the module name only. What is my module name? D flip flop, copy, and here D flip flop, choose the location. This is flip flops. Okay, okay, finish, okay, yes. So this is my D flip flop. So here, copy this. This one here you need to paste, save. So you want to see the elaborated design, you need to right click in the design sources, you need to make set as top module. Okay, come into the simulation, create the simulation, create the file, give the test bench file, copy this and choose the location, flip flop, select OK, finish. Module name is also same. Okay, so my TV file is created. In this, need to copy this code and paste. copy, and here we need to paste. Save. My design is instantiated in the test bench. Okay, and you need to make a stop module for seeing the simulation. We are seeing the D flip-flop, no? So we need to make as a top model. So like this three dots, like a triangle, three dots is coming means this makes the top module. Okay, and open elaborated design. How the tool is converting my code into gate level netlist. I want to see. Okay, so like this, I am getting D flip-flop. Okay, in terms of D flip-flop only, I am getting clock D and two outputs Q and Q bar. So Q bar is giving through the inverter. Okay, and run simulation, run behavioral simulation. You can see in the TCL console also. So whatever we seen in this log file, same thing we are getting. So when so D equal to 0, Q equal to 0, D equal to here D equal to 1, Q equal to 1. Again, during this passage of clock, D equal to 0, Q equal to 0, D equal to 1, Q equal to 1. Okay, you can see in the waveforms also. So here till here, so that means here you see during this passage D equal to 0, Q equal to 0. And during this passage, D equal to 1, Q equal to 1, you are getting. Okay. Again, during this passage, D equal to 0, Q equal to 0. Again, during this passage of clock, D equal to 1, Q equal to 1, you are getting. Okay. So, like this, we can see the waveform in the Vivado. Okay. And next, coming to the quarter sprite. So, here also I created a separate RTL, TB, and SIM. So, file, new project wizard. Yes. Next, so this is same only. So you need to give the module name. So copy this, and here this is D underscore flip-flop. I'll give D underscore flip-flop. Okay. Next, next. So upload the RTL file. D flip-flop. Open. My RTL file is uploaded. Next, choose any FPGA family. Next, next, finish. So now my RTL file is added. Right click, start. Yeah, 0 errors and 1 warning I got. Here go to analysis, netlist viewer, RTL viewer, open. So like this, same as in EDF Vivado, how you got same thing like this, it is converting. Okay, and next coming to the model sim. Okay, so model sim, just quit hyphen sim. It will come out from the simulation. File, new project. Yes, my project name is D underscore flipflop. So the path is same only. Okay. Add the existing files. Add the RTL file. D flip-flop. Add the TB file. D flip-flop. Close. And right click. Compile selected. Yeah, I got tick mark. And in this D flip-flop, right click, simulate. TB file we need to simulate. Now here in this, yeah, waveform is there, no? Just here we need to add the signals. Yeah, right click, add wave. DUT also add wave. We need to group the TB files as well as DUT files. These are the TB files. Right click, group TB. Okay, and next need to group DUT files. Okay, and go to run all. Okay, so you can see in the transcript window also. Okay, I am getting the output in transcript window also. So when d equal to 1, so here d equal to 1, d equal to 0, q equal to 0, d equal to 1, q equal to 1, and d equal to 0, q equal to 0. Again, d equal to 1, q equal to 1. So you can see in the waveforms also. So just to expand this, zoom full. So here you can see during this passage of clock, okay. So d and q I need to check. So d equal to 0, q equal to 0 only. Here if you see d equal to 1, q becomes 1. Okay, q means this one I need to see. And during this passage of clock, d equal to 0, again q equal to 0. During this passage of clock, again d becomes 1, q becomes 1. Okay, see here, this q becomes 1. Okay, this is my q. Okay, so like this we can see in the models. Okay, hope you understood. Okay, so in the next session we'll see about the JK flip flop and T flip flop. Okay, hope you understood. Thank you.